Hey everyone, welcome to the Explainer. So, are you tired of writing custom integrations for every single AI app you build? Well, today we're unlocking the exact mechanics of the Model Context Protocol, or MCP for short. And specifically, we're going to look at this from the client side. If you've ever wanted to give your AI applications a standardized, universal bridge to the outside world, this is exactly how it's done.
Okay, let's map out our roadmap really quick. We're going to cover the universal AI adapter, then speaking the protocol, move into tools, resources, and prompts, talk about building your AI agent, and finally wrap up with debugging and the inspector. All right, part one, the universal AI adapter, and specifically the client's role. So you can really just think of the MCP client as the ultimate universal adapter. It's basically a component sitting directly inside your LLM application, like Claude Desktop, or maybe just a custom Python script you've written. And it maintains a strict one-to-one connection with external servers. It is the single plug your LLM uses to figure out what it can do and actually access the outside world. Now, what's super interesting here is the clear contrast between the two sides of the protocol. The server is, well, it's highly reactive, right? It holds the resources, exposes the tools, and just waits. The client, on the other hand, is proactive. It initiates those connections, it manages the conversation context with the LLM, and it's the one actively requesting to execute those tools. So why are developers absolutely loving this setup? Basically, it's all about modularity. Because the client standardizes the data access, you achieve true LLM independence. You could literally swap out Anthropic's Claude for another LLM entirely, and you wouldn't have to rewrite a single line of your data integration code. Plus, this client layer is exactly where you can easily build in security features, like human-in-the-loop approvals, before a tool actually fires off. Moving right along to Section 2, Speaking the Protocol, JSON RPC 2.0. Everything under the hood here runs on JSON RPC 2.0, and it uses three fundamental message types. You've got requests, which, as you'd guess, always expect a response. You've got responses, which reply to those requests. And then you have notifications. The key thing to remember about a notification is that it has no ID attached to it. It's completely fire and forget. That means whoever sends it, client or server, definitely does not expect an answer back. Every single connection follows this very strict life cycle. It starts with initialization, moves to message exchange, and then ends with termination. But actually, let me put a heavy emphasis on step 1. During initialization, both the client and the server explicitly negotiate and advertise what capabilities they can handle. This is absolutely crucial because it creates a binding contract for the session, which prevents catastrophic runtime errors later on. Listen, to save yourself literally hours of headache, you've got to avoid standard JSON RPC errors like -32602, which stands for invalid params. This specific error pops up all the time if, say, a server tries to send a sampling request to a client, but the client never actually negotiated that capability during initialization. Always check those capabilities up front. Okay, Section 3, Tools, Resources, and Prompts, the three pillars. It really all boils down to these three pillars of MCP. These are the core features a client can request from a server, and collectively, they are exactly what gives your LLM its superpowers. Let's break them down right quick. Tools allow the client to take direct executable actions, like searching the web or, creating a file. Resources are your data sources, and the amazing part is you can use the resources/subscribe capability to get live real-time notifications when that data changes. And finally, prompts. These give your client reusable, predefined templates so you can structure your LLM's interactions perfectly every time. All right, Section 4, Building your AI agent through multi-server orchestration. Okay, picture this. You want to build a highly complex app. How do we combine an AI that rates stories, an AI that generates images, and an AI that researches the live web all into one single cohesive agent? The solution here lies in tools like LangChain's multi-server MCP client. Your main application can essentially act like a conductor, coordinating multiple specialized servers all at the same time. The client routes the creative writing over to the story writer server, the visual prompts to the image generator, and the fact-checking to the Google search server. It wraps all of those different capabilities into one seamless workflow. And honestly, the modularity doesn't stop there. Because of this standardized client-server architecture, the upgrades are practically infinite. You could easily bolt on a text-to-speech server to read those stories aloud, add a translation server to reach a global audience, or just wrap the whole thing in a custom fast API web interface. The protocol makes the whole shebang entirely plug-and-play. Which brings us to Section 5, Debugging and the Inspector.
there's a golden rule straight from the docs, and it's this. The MCP inspector should be your very first stop for testing. Before you go trying to wire up some complex multi-server client application, use the official MCP inspector tool as your ultimate sanity check. It lets you test your server's tools, resources, and prompts in total isolation to ensure they're actually outputting what you think they are.
You actually get two distinct ways to work with the inspector. UI mode runs right in your browser, which is fantastic for interactive exploration and visual testing of your endpoints. CLI mode, on the other hand, runs in your terminal. It's highly scriptable, spits out direct JSON, and is absolutely perfect for rapid feedback loops or plugging right into your automated CI/CD testing pipelines.
Now, if you're hitting a wall, just run through these rapid-fire sanity checks. First up, always use absolute file paths in your configurations, never relative ones. Second, and please, this is a huge one. If you're using the standard input-output transport, your server must never log to standard out. If it does, it will corrupt the protocol messages. Always log your debugging info to standard error. Okay, I need to give you a critical security warning real quick regarding the inspector proxy. There is an environment variable called dangerously omit off. Do not use it unless you completely wrap your head around the risks. Disabling authentication on the inspector proxy can literally expose your machine to remote code execution just by visiting a malicious website. So yeah, always keep authentication enabled.
So we've covered the architecture, the protocol rules, the capabilities, and the debugging tools that make the MCP client such a massive, game-changing leap forward for application development. The power to instantly connect any LLM to any data source is officially in your hands. So go grab the SDKs, start connecting your servers, and the only real question left is, what kind of universal AI agent will you build next?